Hello everybody, this is Math with Josh. This is just a short video on the commutative property. I'm going to make a few short videos for all of these little algebraic properties. The commutative property is that an operation of two numbers is commutative if reversing the order of the two numbers doesn't change the output or result, and it's not commutative if that operation ever changes answer when you change the order of the numbers. So most classically, addition is commutative because, to pick an example, 3 plus 4 equals 7, and 4 plus 3 also equals 7. Now, so we're thinking properly about logic. This is just an example of the fact that addition is commutative. That is, in addition, we can say all the time that if we add some number we'll call A to some number we'll call B, and the answer would be C, then we also know that if we were to add B to A, we would also get C. That's what it means for an operation to be commutative. Right? If for every A or B, that is any two numbers, if we can flip the order in the operation and get the same answer, then the operation is commutative. This also works for multiplication. Let's do some erasing here. So with multiplication, we remember that, let's say 2 times 5 is 10. And of course, 5 times 2 is also 10. Now for addition, I think it's obvious why this is true. That is, if I hand you 3 apples, then 4 apples, or I hand you 4 apples, then 3 apples, you end up with the same number of apples. I think for multiplication, a very overly simplistic visual to think about is, let's see. So if we think of 2 times 5, 2 times 5 apples, and we think of 5 times 2 apples, what we notice, besides my lack of drawing skill as always, what we notice is that, of course, this 5 times 2 is the same as sort of rotating this 2 times 5. And you can imagine and think about for yourself that this will work for any multiplication problem. It's very clear how it works for positive numbers especially. So that's the commutative property, and that's the rule. Now it's also important, I think, to look at an operation where the commutative property does not hold. And one good example is subtraction. So let's see. So 10 minus 4. 10 minus 4 is 6. But subtraction is not commutative in this sense, because if we write 4 minus 10, we get negative 6. And because 6 and negative 6 are different numbers, this actually proves, because we only need one example, this proves that subtraction is not a commutative operation. Division, for a similar reason, I'll leave that as a little bit of homework to check out and look at the fact that division is not commutative. So that's all for this little video. Thank you very much for watching, everyone. Once again, this is Math with Josh, and have a nice day.